On to number 26 through 31. Instructions are to perform indicated operation and simplify. So if you take a look at 26, we're multiplying with radical expressions, which makes it a little more challenging than when we just have x's. But 26, we have a binomial times a binomial. So 3 plus the square root of 3 times 4 plus 4 square roots of 3. So what we actually end up doing is foiling, just like we've seen with polynomials. So we'll end up doing 3 times 4 to get 12, and 3 times 4 square roots of 3. So notice that the 3 and the 4 are going to multiply together to become 12. But my square root of 3 here doesn't have a square root on this side to multiply with. So it's just going to come down as square root of 3. So we're finished with the 3, and now we need to come and pick up our square root of 3 and multiply it over here. So same deal here. The 4 doesn't have a square root to multiply with the 3. You could think of there being a 1 though in front of the square root of 3. So 4 times 1 square root of 3 would be 4 square roots of 3. And then we multiply square root of 3 times 4 square roots of 3. So 1 times 4 would be 4. And then we have the square root of 3 times 3. We multiply those insides to get square root of 9. So after this point, we need to start simplifying. So it really doesn't matter what you start with, but we could just start with 12 square roots of 3 plus 4 square roots of 3. So that would be 12 plus 16 square roots of 3 plus 4 square roots of 9. So if you look around, you might not see anything to do, but if you look a little closer, square root of 9, we can figure out what that is. We know that the square root of 9 is 3. So this would really be 12 plus 16 square roots of 3 plus 4 times, and we said the square root of 9 is 3, so that would come down as a times 3. And then now that we've taken that square root, we've actually created more simplification to do. 4 times 3 is 12. So bring everything down. We have 12 plus 16 square roots of 3 plus 12. And again, we've created more like terms. 12 plus 12. We can combine those to get 24, and then bring over our 16 square roots of 3. So these are multiplied the same way as like maybe an x plus 2 times 2x minus 3 would be, but the simplification is a little bit more complicated because sometimes you can simplify those square roots, so you always want to look out for those. So take a look at 27. We have the square root of x plus 6 squared. So this is probably the third problem we've seen that's a binomial squared. So by now, we should know that we have to expand. So we have to expand. So this is actually the square root of x plus 6 times square root of x plus 6. So it's a binomial times a binomial. We will need to FOIL. So square root of x times square root of x would be the square root of x squared. And then square root of x times 6, the 6 is not inside a square root, so it's just going to multiply to the outside of our square root of x. And then we will come back and pick up this 6. It needs to multiply to a square root of x. We'll get another 6 square roots of x. And then 6 times 6 would give us 36. So if we look through here for some things to do, I see a couple of things. First, I know that the square root of x squared is really just x. And then we also have some like terms. So we have 6 square roots of x right here plus another 6 square roots of x. So that would be plus 12 square roots of x. And then 36 doesn't have any like terms, so it's just going to come down. And we will be done with 27. So if we take a look at the next ones, 28, we have the square root of 8 minus 2 times 3 square roots of 8 plus 5. So again, binomial times binomial, we know we need to FOIL. We can do the square root of 8 times 3 square roots of 8, which will be 3 square roots of, and then if we do 8 times 8, we'll get 64. The square root of 8 times 5, so 5 is just going to go to the outside because it's not inside a radical, so we'll have 5 square roots of 8. Come back and pick up our negative 2. Negative 2 and 3 are both on the outside, so we would multiply those guys to get a negative 6 square root of 8. And negative 2 times 5, we will get negative 10. So at this point, we want to start looking for things to simplify. We know that the square root of 64 is 8. So this 3 is going to come down. It's still going to multiply by the square root of 64. It's just that the square root of 64 will now be 8. And then also notice that you have some like terms here. 5 square roots of 8 minus 6 square roots of 8 gives us minus 1 square root of 8. So the 1 would be implied with the minus sign. We don't have to write it. And then our minus 10 will just come down. So we can go ahead and do 3 times 8, which is 24, minus the square root of 8, minus 10. We've created more like terms again. 24 minus 10 will give us 14 minus that square root of 8. And now we have our final answer. (29) through 31, we are still multiplying, but we no longer have radicals. We actually have complex numbers. So complex number has that I in it, the imaginary number. So something that we do need to keep in mind is that I squared equals negative 1. So we want to make sure we remember that as we're working through these problems, because if I squared pops up in anywhere in our answer, we will need to replace it with this negative 1 right here. So we want to hang on to this. But for now, we have a binomial times a binomial, so we'll FOIL. So we can do 2 times 5 to get 10. 2 times negative 4i, which is a negative 8i. Now we come back, pick up 7i times 5, which is 35i. And 7i times negative 4i, which is a negative 28i squared. So we can work towards collecting some like terms here. We have negative 8i plus 35i. So we're going to have 10 plus 27i minus 28i squared. And remember, I told you guys to look out for that I squared. So it's popped up right there. So I need to replace it with that negative 1. So we're going to have 10 plus 27i minus 28 times, and instead of I squared, plug in that negative 1. And all it really does is changes the sign, but it turns that imaginary number into a real number. So we have 10 plus 27i, and then negative 28 times negative 1 would be plus 28. And I've just created new like terms. 10 plus 28, that would be 38, and bring over your plus 27i. So remember, with complex numbers, the real part should go first, that's the one in pink, and your imaginary part should go second, which is your black 27i. So you should have it in that format every time. If we take a look at 30, we see another binomial squared. So by now we should know that we need to first expand. That's going to be 3 minus 2i times another 3 minus 2i. So binomial times binomial, I'm going to FOIL. So first terms, 3 times 3 will get 9. 3 times negative 2i would be a negative 6i. Come and pick up our negative 2i times 3 for another negative 6i. And negative 2i times negative 2i would make a positive 4i squared. Work towards combining some like terms. Negative 6i minus 6i, those are like terms, so we're going to have 9 minus 12i plus 4i squared, and everything looks nice and simplified except that we see again this I squared. So we're going to have to replace that with a negative 1. We're going to have 9 minus 12i plus 4 times, plug in that negative 1, and we'll get 9 minus 12i minus 4. Like terms, 9 minus 4 would give us 5, and bring down your minus 12i. So simplified again. So our last one, still complex numbers, binomial times binomial, so we will do the same process again. 9 times 9 will give us our 81. 9 times negative 2i would be a negative 18i. Pick up the 2i, multiply it to the 9, get 18i plus this time, and 2i times negative 2i would be a negative 4i squared. So work towards collecting those like terms. So negative 18i plus 18i, those are completely gone, they cancel. And I'm left with 81 minus 4i squared. And again, if you see an I squared there, you should fix it. So we have 81 minus 4 times, instead of I squared, we replace it with negative 1. We'll end up with 81, and negative 4 times negative 1 would be a plus 4. 81 plus 4 gives you 85.